just list a few properties and give some examples. Properties of addition you're going to see are the why we do math the way we do. Long, long time ago in a land far, far away, they came up with some rules for doing math. And so these properties are going to be these rules. And some of these rules you're going to look like and say, duh, exactly. Okay? But it gives us exactly why we can do. And you don't really need properties so much in algebra, what we're doing, but they are very important as you go into algebra 2 and geometry and calculus to do big, big, big problems. And so you know exactly what order to go through. Properties of addition. The first one we're going to write down is the commutative property. What is the root word of commutative? Commute. What does commute mean? No. That is close. Okay? If I'm commuting to college every day and then I come back home, what am I doing? I'm traveling or I'm moving. Okay, the commutative property says the order of addends does not matter. And the example that we'll write down is A plus B equals B plus A. Once again, this tells me that it doesn't matter which order I add them in, I'm still going to get the exact same answer. Make sense? Can somebody give me a real life problem instead of using variables? Quickly, anybody?
3 cats
Lucy.
plus 2 dogs. 4 plus 6 equals 6 plus 4.
Exactly. Okay? 4 cats plus 2 dogs equals 2 dogs plus 4 cats. Okay? Next one, associative property. You're thinking, oh good, I'm going to get to abbreviate these things. You cannot abbreviate the associative property with any less than 5 letters. Okay? You'll get that in a few minutes. You must use at least 5 letters to abbreviate the associative property. What is the root word of associative? Associate. What does it mean to associate? Yes, but when we're talking about people, what does it mean to associate? Talk with a group. Exactly. Okay? So the associative property says that the way you group addends does not change the sum. The example that we're going to write down is the quantity of A plus B plus C equals A plus the quantity of B plus C. What is different about these two sides? What's in parentheses? On the left-hand side, we have A and B in parentheses because A is having a conversation with B and see you later. Okay? We got A and B having a conversation. Well, then A needs to go get some punch from the punch bowl. So now B and C are having a conversation. Okay? A is still in the room, but now B and C are having a conversation. We changed grouping, but is the sum going to change? No, it's not. Okay? Now, what property are these of? These are properties of what? Addition. Does this work for subtraction? No. Okay, it does not. We're going to get to different properties of all of those things, but this is only for addition when we're adding each of those things. Any questions so far? Okay? Question? Okay, great. Next one is the identity property. This one is going to blow your mind. The identity property. The sum of a number and 0 is that number. Mind blown yet? Okay, they had to come up with a rule that says A plus 0 equals A. Any questions about that one? We're good? Just remember identity. The identity of the number does not change. Okay, little clue to help you remember that one. The identity of this number does not change when I add 0. Who said something? Yes, Steve.
It's rocket science.
Rocket science, absolutely. Okay. And the last property of addition that we're going to talk about today is the inverse property. The inverse property says the sum of a number and its opposite is, anybody? 0. If I'm using the inverse property, then I would say A plus what?
Negative.
Negative A equals 0. We good? Any questions? Okay. We're going to go over how and why we use these as soon as we get done with the multiplication properties. Skip 2 lines, please. And we're going to write the properties of multiplication. Actually, yeah, go ahead, keep going. The first property of skip a line, the first property of multiplication is the commutative property. Can somebody take the commutative property of addition and change it so that it fits with multiplication? Stephen? Give me the phrase, the word phrase first. What did we say was the description of the commutative property of addition? The order of addings doesn't matter, so how would I change that for multiplication?
The order of factors does not.
Absolutely. The order of factors does not matter. Now, what example would I use? Stephen? Exactly. And we're going to, it doesn't matter if you use the dot between them or you don't use anything between them, either one's fine. The example is A times B equals B times A, or AB equals BA. Again, commutative, the root is to commute or to move, so I can move them to change the order, and we're still okay. Everybody okay? How about the associative property Can somebody rearrange the description from addition to make it fit for multiplication? Stephen?
The way you group the factors doesn't change the product.
Exactly. The way you group the factors does not change the product. And how would I write that as an example? How would I write that as an example? Somebody whose name does not start with Stephen. Anybody? A times B in parentheses times C equals?
A times B and C equals C.
Exactly. Everybody good? Got it? If you need to turn the page, you're welcome to, just right on back. Now we have the identity property. This one's a little bit different. The identity of property of multiplication says that a number times 1 equals that same number. So our example for this one would be A times 1 equals what? A. Once again, the identity of the number does not change when I multiply it by 1. Everybody good? The next one is the property of 0. The property of 0. Anybody guess what the property of 0 says?
Number
Okay.
times 0 is 0.
Absolutely. A number times 0 equals 0. Our example would be A times 0 equals 0. And the last one we will talk about today is the property of -1. The description for the property of -1 is a number times -1 equals the opposite of the number. So our example would be A times -1 equals -A. We good? Now let's do some examples. So just skip a line and write examples, and we're going to do several examples and show why they are the property that they are. Example number 1. X plus 5 equals 5 plus x. Look through your properties and figure out which property is demonstrated in this example. When you know it, raise your hand.